Hi guys, good evening everybody. Hope you're all doing good. I'm super excited to welcome you all again on the day 2 of IWCON. I am Shravani, member of Infosec Write-Ups, and today's session is brought to you by our sponsors Hackru, Zero Point Security, Yes We Hack, Patchain, Saptang Labs, and our community partners. So for today's talk, we have Blake McDermott, who who does DFIR within Microsoft Dart. So today he's gonna talk about the good, bad, and the ugly of IIS modules. So we are super excited to have Blake. So also guys, there will be a Q&A session after the talk. Blake will be taking your queries, and also please share your screenshots and tag us on Twitter. And whoever wants only the swag, please also add the hashtag IWSwag. So I'm welcome Blake onto the stage now. Hi Blake,
Fantastic. Hello. Thank you very much for having
we
me.
are super excited to have you.
Fantastic.
So I'm handing you the stage you to now.
All right. Can I just get confirmation that the screen's sharing?
Yes, yes, sure. Please share your screen. I'll come.
All right. Thanks for everyone for coming along to my talk. As mentioned, we're going to be talking about IIS modules and kind of the evolution of how web shells have evolved. So quickly, who am I? I'm a hunter and developer within Microsoft Dart. I have a history in my previous lives of detection and preventative engineering, some work within the Windows kernel, as well as doing a bit of malware development for capture the flag sake. Essentially, I love finding weird little quirks for hard to detect malware, like you'll see with this. So, what are we going to talk about today? We're going to go through pretty in depth into what IIS modules are and how they work. We're going to be looking at a lot of annotated C#, but I'll do my best to explain it as we go if you're not familiar. We're going to talk about the malicious uses of IIS modules, some detection techniques, and how we can use IIS modules for good. I'm also going to be showing some defender from endpoint queries, but you can take any of this logic and throw it against your EDR. So, after about 7 years of doing incident response, I went back and did some analytics on the incidents that I've seen over those 7 years. About 89% of incidents that I had been involved with had some form of web exploitation. Usually, this was as the intrusion vector or persistence through the use of web shells, which really showed that external facing web servers are a huge risk to any network. Initial access was usually through a third-party vulnerability rather than through a vulnerability in IIS itself. IIS modules were a feature added in IIS 7 back in 2008. They allow for additional capability to be added to a website through DLLs rather than building it into the ASPX website. There are two types of modules: native modules, which are usually written in C or C++, and managed modules, which instead use C# and gain the full power of .NET. Modern OSs have at least .NET Framework 4.5 installed on Windows. Managed modules have their main class inherit the IHTTP module. This inheritance forces two mandatory functions, the init and dispose functions. Init will be the function that is called when a module is loaded. It's often used to set event handlers. Event handlers are essentially functions that are called when an event triggers. An event might be as simple as a web request being made to the web server. Managed modules can be handled on a per site level or on all websites referred to as globally. If we look at the zoom in of the code, at point 1, we can see the shell class inheriting the IHTTP module, the init function, which gets past the HTTP application, which is a representation of the specific web service that this module is installed on. At point 3, we can choose the event triggers that we want to hook from this HTTP application. And then at point 4, we assign the event handlers. These event handlers are functions that will be called when that event triggers. So these are pretty self-explanatory. Begin request when a request happens, end request when a request is ending, or error when an error occurs. Then at point 5, we can see the dispose function. We can leave this blank unless we want to do some cleanup after ourselves, such as removing our event handlers. Most common way to install modules is through the GUI. Again, this can be done at a per site or at a global level. At point 1, we can add a new managed module. Point 2, we can assign it any name that we want. And then at point 3, we can pick which class we want to use. And these classes are the ones that inherit that IHTTP module. Our module will either need to be located within the global assembly cache or within the website's bin directory to be detected here. Alternatively, rather than using the GUI, we can instead use the command line options to install our module within the Global Assembly Cache, or GAC. The GAC is a list of .NET modules that can be accessed by any .NET program. Once a module is installed within the GAC, the app.cmd binary located within inetserv can then install the module from the GAC. It's worth mentioning that the GAC binaries are required to be signed, but there's no validation on the signature. GAC binaries are located within the .NET assembly folder by default. So let's talk about how these IIS modules have been used maliciously, starting with a bit of a history. From a couple of Google searches, the earliest evidence I could find of malicious IIS modules went back to 2013. They were used by crime groups where they would install a filter on payment pages to steal payment info and credentials. This technique is still possible. A friend of mine actually got hit by this technique a couple of weeks ago. The IIS module is post-SSL decryption, so it's very easy to get clear text PII, but they weren't very common. Web shells were just a lot less effort and easier to install. A more recent documentation of malicious IIS modules was the CrowdStrike report on ISAPL. Initial discovery of this post-exploitation framework was 2021. This malicious IIS module was pretty bare bones, but had the modulated approach. All it could do was receive commands and load further modules reflectively. These modules provided a whole suite of functionality, and a big reason why it was hard to detect was that it executed within the context of W3WP. So the standard web shell detection of looking for child processes wouldn't work. Then this year, a couple of months ago, Microsoft released a blog where IIS modules had been seen more recently in the wild. The actor used a less sophisticated module to the ISAPL, but still extremely effective. Rather than loading modules reflectively, they opted for process creation. Using the Power SHDLL, they could execute arbitrary PowerShell through RunDLL rather than the standard PowerShell child processes. Active commands to the IIS module were hidden within the cookies to the pages with the GIF extension. So we know that IIS modules can do module loading reflectively, but what does that mean? This is a super common term in cybersecurity. For example, reflective DLL injection is the default method of loading modules used by Cobalt Strike. Normally, we would load a module from disk using a file path to its current location, but reflective loading instead loads the module directly from memory. Simply, this approach works in 3 steps. Allocate some memory, copy the module into the newly allocated memory, then create a new thread to execute that module. This module will then execute under the context of the process it was loaded under, just in the newly created thread. Because there is no file path and it's not loaded through standard module loading techniques, this is a defensive evasion against module listing, as reflectively loaded modules won't appear in module listings. C# has a super easy method of reflectively loading modules using the system reflection assembly load method, or function if you use Python. This code snippet shows how C# can load the encoded blob where the decoded blob doesn't touch disk. At dot point 1, we can see that the encoded blob is stored statically within the file. At dot point 2, we can allocate the memory for the decoded blob. We then decode it into the new memory allocation. And at dot point 3, we call assembly load on the new memory allocation, invoking it by calling its main function. A couple of months ago, you could load pretty much whatever module you wanted into W3WP, but since the not proxy shell, Defender has been, and a lot of other products have been monitoring a lot more on these assembly loads within W3WP. In most cases, assemblies are going to be accessible in one of 2 ways. The first method is through static blobs. Normally, this is a base64 blob sitting within the binary, but this may also be provided in a web request. The encoded binary can then be decoded or decrypted in memory, then reflectively loaded. This can prevent the decoded binary from hitting disk. The second method is more dynamic, downloading the binary from an actor-controlled C2. This can still be encoded or encrypted, but less commonly, as a lot of EDRs aren't going to be checking for the binaries that get downloaded or loaded within W3WP. This is also a better way of detecting bypassing AD as well, because if you're downloading it directly from a C2, there's no static blob that a antivirus might pick up on. For my proof of concept, I was just using a hard-coded address to download further modules such as sharpound and sweet potato, while a more sophisticated module could pass the C2 information in the request. At point 1, we can create a web client downloading the SH binary from a 192 address into a byte array. That byte array is then passed into assembly load to get our reflective loading. Sharpound doesn't touch disk in this instance. At dot point 2, we can use our assembly object to call 2 functions, with the second one being invoke sharpound. The last line shows that I set the output directory to program data. And interesting enough, we've seen that some EDRs won't actually capture the W3WP connection leaving the network because of this weird loading, I'm guessing. One of the best examples of loading modules is embedding sweet potato or any of the potato families of privesks. This can give the actor direct execution of system on most IIS servers, allowing them to further dump credentials or drop a more evasive implant. In the image on the right, you can see that the W3WP process was seen setting up a fake printer spooler for privilege escalation through the sweet potato privesk. With Sweet Potato, I usually use two arguments. SPA is the standard argument command, or TAC-A, that lets us execute arbitrary commands as system, while SPP executes a program. Depending on the OS, one may be more reliable than the other. So we've talked about techniques that this web shell can use to load modules and get execution, but how do you get your commands to the web shell? This shell is particularly cool because you're not reliant on a specific web page like most web shells. Using a few techniques that we'll cover in a second, IIS modules can hide their commands in any request rather than on a specific page. We spoke earlier about event handlers. IIS modules have 27 built-in event handlers, but my favorite four are generally BeginRequest, EndRequest, Error, and LogRequest. The names are pretty self-explanatory. For example, BeginRequest triggers whenever a web request is made to the server. Just to reiterate, the IHTTP module structure within the init function is the standard place to set up these event handlers. We can see that at point 3 and 4. You can see the event handlers for BeginRequest, EndRequest, and Error, calling the onBegin, onEnd, and onError functions. Using these functions, we can essentially set up a proxy, intercepting all requests before the website can process them, and we also get the final say on responses that the server sends back to the client before they're sent. We can use the BeginRequest trigger to intercept every request before it reaches the web server application. As we can hide the commands anywhere in the request, this essentially makes every page a web shell. Full read and write control of the request and response also makes it that we can remove our malicious communications from the request before IIS or the website has a chance to process it. This means that we can send our own custom responses back to the client. This is a long list of all the areas that we can hide web shell communications. My favorites are hidden in red, but they are not all of them. Whether it's hiding it in the HTTP method, the parameters, the cookies, or the user agent, IIS modules give a huge amount of flexibility in how they hide themselves. My preferred method of commands is parameters. Visiting a web page, we can just put a question mark followed by the key and value we want to provide. I have a quick loop that checks each parameter in a request for any of our malicious parameters. This is also super simple too. You could build a web shell controller to help make the user experience better, or you can just use a web browser. Due to the read-write access we have, standard IIS log detection can be extremely ineffective against IIS modules. We can't apply the same kind of detection, such as looking for multiple posts to the same page, or even known bad IP addresses, as the IIS module can modify all the content before it's written to the log. You may be able to detect a pattern in how it rewrites the requests, but it is still inconvenient. Something that we only briefly covered earlier is that the credential stealing. Rather than using IIS modules as an implant, you can use it for persistent access to a network. Say you installed IIS modules on a Jira server. Every time someone logs into the server, you could have the IIS module capture credentials and send the credentials back to a C2. So even after you kind of get cleaned up on a network, you can still maintain access and get new credentials. This is a super simple example on the left. If the requested page has login.aspx in the path, copy the values from the form values for user and password keys, then upload them to an external C2. Similar to other examples, a more sophisticated version of this could probably instead reflectively load a separate module for credential stealing, so we don't have any of this code embedded directly into our base IIS module. The last technique I wanted to cover is request tampering. We've talked about how IIS modules can be used to compromise a server providing persistent access, but what about end users? Hypothetically, if someone wanted to keep tabs on everyone visiting a website, they could compromise the website and install an IIS module that will deliver malicious JavaScript payloads whenever someone visits the website. Because this is post-processing on the website, it could be quite difficult to actually capture if you don't have some form of packet capturing. So let's talk about detection. We've talked about a lot of cool evasion techniques. So how do we detect it? Some of the best detections for this kind of activity is actually disabled by default. There are multiple different ETW providers for IIS, and today we're going to talk specifically about the IIS configuration operational EBTX. We can enable this log through WebUtil, and you can see the commands in red. Just noting that I don't have much time left, I'm going to skip through some of this a bit quickly. But if we enable this event log, one of the really useful event IDs is event ID 29. This is going to create an event whenever a IIS module is added to a website. For most websites, it's not common for IIS modules getting added, so this can be a good event ID to flag on in your SIEM. Event ID 29 also shows when a module is uninstalled. Again, not very common for production websites, so it can be really good to detect. Monitoring for installation through GAC-util and appcmd is also a great step as well. We've seen in a few cases, such as the example on the left, where actors have dropped a very simple web shell before uploading a IIS module web shell. If you have a look at the start and the end of the command on the left, that's cmd/c cd, and the following cd and echo is signs of China Chopper web shells generally. So an actor used a China Chopper web shell to install a malicious IIS module. It can also be really useful to monitor for web.config modifications. Within the web.config, we'll have a list of all modules installed on the website. You can see here the add name backdoor. Within the Microsoft IIS configuration operation, there will also be a event ID 23 whenever a change to the web.config is made. It won't tell you what the changes are, so it can be great. It's an important step to make sure you have a backup of your web.config to compare against the production version in case any malicious changes are made. IIS modules can be listed through the appcmd command. These modules are listed in the order that they were added to the website. We can see our two malicious modules down the bottom in red. The type is the class that was being called, and you can see that they both call the same class. Using MDE, we can see IIS modules being loaded by the W3WP process through the device image load events table, but what's particularly interesting is the timing that these modules get loaded. Time-based analysis of the modules being loaded into W3WP can help detect unauthorized module loads. Grouping together module loads by the second that they're loaded, you can see that the legitimate modules were loaded within 3 seconds of the W3WP process starting. Then 4 hours later, we can see the malicious proxy shell module being loaded. There were no other modules loaded outside of that proxy shell module. So time-based analysis is one of the best detections we have for this. At some point, the actor is going to want to leave the W3WP process, whether it's to move laterally through the network or to elevate their privileges through something like Sweet Potato. This command is in the Azure Sentinel GitHub, and it's just an example of how you can hunt for malicious child processes at W3WP. This is very similar to any other web shell hunting. Another really useful ETW is the .NET Runtime Rundown. This log is not enabled by default, but it will give you a snapshot in time of all the IIS modules loaded within a process. For each module loaded, there will be two events. The event ID 151, which shows the app domain name or namespace of the loaded module, and event ID 155 shows a list of all modules loaded through assembly.load. So far, we've found two reflective loading techniques through the ETW logs. Firstly, the path of the module does not appear. It will just be the name of the module. You can see in red, ## doesn't have a path, while the other assemblies do. Secondly, there will be no assembly flags. If you look at the process hacker output on the right, you can see that there is no flags there. The other modules not in red, rectangular, are either additional modules brought along by ## or the Visual Studio debugging the W3WP process. So let's spend some time talking about how web shells can be used, how these IIS modules can be used for good. Because we've already talked about a lot of these features, we could actually create our own IIS module to incept requests with known bad features, such as an unknown parameters or over a size limit. We can use the .NET capability to create ETW event, to create a ETW or EBTX provider and directly ingest into our scene and prevent known bad indicators. For example, we get full access to the request and response of all traffic. If we're responding to an incident and we know that an actor is using a specific web shell, file name, parameter, whatever, we could install an IIS module that detects those malicious indicators and blocks them quietly. If we use a tactical agent like this against something like China Chopper, we could use it to intercept and log commands, files being uploaded or files being downloaded. We could filter on the known bad parameters provided in the shell on the file name, since no legitimate users should be accessing that file, or on the IP addresses that the actor was using. A more recent example that we could talk about is the Exchange vulnerabilities that came out a few months ago. This one can be a bit more complicated because we can set up multiple clauses before it's intercepted. We could set up a check that searches for the email parameter with a value that starts with autodiscover.json. We know that the request needs to be authenticated, and we can also do a search for source IPs that are known to be throwing around this exploitation. If we see a request that matches these parameters, we can then block the request before Exchange has a chance to process it. To lessen the load, we could also install this just on the web service one. Exchange sets up multiple web services, so we can ensure that we only install it on the web service that we call about. This way, we'll be able to block suspicious requests before they even get a chance for the server to process it. So, in conclusion, IIS modules are extremely powerful, whether they're being used by the red team or the blue team. More sophisticated versions of these IIS modules are becoming more common. And they can also be super useful for responding to compromises. So it's probably worth going back through some of these detection techniques and making sure that they're enabled throughout your network. But that is all that I have for today. Thank you very much.
That was such an interesting talk, Blake. Thank you so much.
Not a problem. Thank you very much for having me.
So our attendees has a few questions. So would you like to take them up?
Yeah, absolutely.
The first question is by Bhavesh. He asks, what are some common vulnerabilities that can affect IIS modules?
Um, I don't really know that many common vulnerabilities because usually they're written by third-party vendors if they are legitimate IIS modules. But normally, what we would see is whether it's through common, just standard IIS vulnerabilities, you can upload a file, you'd be able to upload a module and install it that way. So there's no real, at least common vulnerabilities within the IIS modules themselves. But with any third party library, there's definitely that possibility there.
So the next question is by Aryan. He asks, during looking out for malicious IIS modules, what's your take on event handlers like begin request, end request, error, log request for security mitigations?
Great question. So there's definitely going to be a lot of legitimate uses for those kind of things. And because at least .NET modules can be pretty easy to reverse to get an idea of what processes, what modules are using them, getting a better understanding of kind of the baseline for your network of what modules do have these hooks by default, and monitoring for new modules that get dropped and start hooking into these is very important.
So the next question is by Alvin. He asks, what is really the purpose of the application pool in IIS?
Great question. It's to kind of separate what user credentials or service account that IIS is operating under. Back in the day, it was very common that all web services would just run a system, which wasn't ideal. So then they started having web servers run as network services, just so rather than running a system, you're running under a less privileged thing. And kind of as the next security mitigation afterwards, application pools became a specific user almost that each web service can run under. So you can customize the specific permissions required just to make sure that each web service only gets exactly what it needs to be able to run.
So the next question is from Infosec write-ups only. The question is MDE loaded module slide. What is that syntax and tool to query data?
Yes, so that is KQL or the Custo query language. That's kind of Microsoft's query language for a lot of our security tools. So it's very much like SQL, but yeah, it's a good language.
Rohan Gupta says it would be great if you could share your slides.
Yeah, we can definitely look
Yes,
at a
definitely. You can
opportunity.
just mail us. Then uh, we will see that we will mail our attendees the same slides.
Yeah, fantastic. We can set up a PDF for that.
Yeah. So there is Jagdish who has raised hand. So would you like to interact with him, Blake?
Yeah, absolutely.
So Jagdish, hi Jagdish. Okay, I think. is no more available. It was great interacting with you, Blake. It was such an
Yeah.
exciting and insightful talk. I hope everybody has had a great time listening you.
It was great coming here. Thank you very much again for having me.
Thank you
Um,
so much.
Thank you. Goodbye.
So, people, I hope you all enjoyed the talk by Blake. Also, please take the screenshots and tag us at the rate infosec.com. And to win the giveaways are Pentester Lab Pro 1 month coupon, Burp Bounty Pro annual license, and IW swag. So if you are only interested in the swag, please use hashtag IW swag. So the networking session and lounges are open until the next talk. So please hang out there and have a great time.